So a problem that we would have done in 7.4 would look something like that. And I know a lot of you are used to calling those, that's radical 16 x to the fourth to you. You really need to start being specific about what root you're talking about. I don't really know why people would prefer that you just call it a radical. I know it's quicker to say, I guess, than cubed root or whatever, but you really need to be specific. If you call that a square root, then you actually know what you're talking about. So when I say what's the square root of 16, you know what I'm talking about. If you call it radical your whole life, you don't even know what a square root is. So you really need to start focusing on calling that a square root. So what times itself is 16? 4, we know that. And to simplify that exponent there, we divide by the index, which is 2, which would leave us with x squared. So we did that in section 4. That should be total review, no problem. Today, what the difference is, we still have 16x to the fourth, maybe, and then we have a y to the 7th. So what's the problem there? You can't. Specifically, what can't you do? Even. Divide 7 by 2. So the rest of this is still going to be 4x squared. The square root of those things, take it one at a time, 4x squared. But you can't take 7 divided by 2 either. So what you have to do for these problems is drop down until you can get a number divided that will divide by 2. So what's the number less than 7 that would divide by 2? 6. So if you divide 6 by 2, you'd end up with y to the third. And how many y's above 6 do we have left? Just the 1. And you leave that under the radical. 4x squared y cubed square root of y. So any that you can't divide out evenly, you drop down to a number that you can, and then whatever's left stays under the radical. That's one of the differences. So a lot of your homework problems will be very similar to last section with this little bit of difference in there. Now the other thing you need to remember is our index, was it odd or even? Even, and we ended up with an odd exponent. What does that mean? What do we have to do? You have to put that one in absolute value. So just remember to look out for those as we go through. Something we've done before, rationalizing the denominator. You cannot finish a problem and leave a radical of any kind, be it square root, cube root. You cannot leave one of those in the denominator. So we have a method called rationalizing in order to get that radical out of the bottom of a fraction. We'll start off with something very simple here. Just 1 over the square root of x. You can't do anything to that. You can't divide that. You can't simplify that. It's already simplified. But you've got an issue. You have a radical in the denominator. In this case, you have a square root x in the denominator. So what rationalizing means is you're going to multiply by whatever that radical is on the top and the bottom. And you'll see why we do that. So on top, we have 1 times the square root of x. What would that equal? What? The square root of x, anything times 1. And what are we going to get on the bottom? Just plain x. And that's an important lesson that you'll have to know as we go through this whole section. If you have the exact same radical and the exact same number underneath, all that happens when you multiply them is the radical cancels. And you end up with whatever this is. In this case, it's just x. So it cancels the radical. So if you do, and I would write this down, if you do square root 3 times square root 3, what do you get? You end up with 3. Another way to look at that is 3 times 3 is what? So what's the square root of 9? 3. Either way you do that. But it's helpful just to remember, if you multiply the exact same radical, you end up with just the number underneath. So if you multiply square root 3 times the square root of 2, what do you think that equals? Yeah, square root of 6. So that doesn't work the same if it's not the exact same radical with the same number underneath. You just have to multiply that and then simplify if you can. But if you multiply the exact same radical, it just cancels that radical sign. X to the 4th over y to the 5th. What do we always do when we have a fraction underneath? Fraction underneath the radical. Split them up into 2, so we have the square root of x to the 4th over the square root of y to the 5th. The top one we can simplify easily. What does that give us? X squared, no radical. On the bottom, we've got to use the rule we learned up above, because you can't divide 5 by 2. What can you divide by 2? 4. So that's going to leave you with y squared. What else? Y squared, square root y. So we've simplified both of those. But what's the problem? Got a radical in the bottom. What do we need to multiply by? Square root of y. On the top and the bottom. You would if it was an odd. Remember, if your index is even and your ending exponent is odd, that's when you put it in absolute value. So on top then, how are we going to combine those? You can't. You can't actually multiply them. You just write x squared times square root y. You can't combine them. You just put them side by side. Means you're multiplying them. And then on the bottom, what's going to happen when you multiply these two things? The radical will cancel and you will have what? Y. So you have y squared times y. Because this becomes y. What is y squared times y? Y to the 3rd. And that's what you would end up with on the bottom. Let's flip over to page 410. We will be doing multiplying, adding and subtracting, and dividing in this section, so we still have a long way to go. 6 times the cube root of 9x squared. Times 3 times the cube root of 24x. What you need to look at here is these numbers have two different parts. You get this number out front, the 6, that's just plain 6. That's 6 times the cube root of 9x squared. So you've got these numbers out front, the 6 and the 3, and then you've got your radical part. You kind of deal with each one of those separately. So you need to realize that as you're working the problem. So the first thing, since you are multiplying, sign in the middle there, you simply do multiply these two numbers together. 6 times 3, 18. And then you can also multiply those numbers underneath. Now that's cube root. And what is 9 times 24? You will all need your calculators out as we move through here. We'll be simplifying some big numbers, big radicals. What is 9 times 24? 216. And we would have x to the what? X to the 3rd. So we've combined that down. Now we've just got one number instead of two separate ones. And we have to simplify the cube root of 216, x to the third. You still got your 18 out front, and it is times. So what's the cube root of 216? Is that a perfect? It is a perfect cube. 6 times 6 times 6 is 216. So the cube root of 216 is 6, and what's the cube root of x to the third? That would cancel out and leave you with x. And then you just finally multiply those two numbers. 108x for your final. And I get 216. Let's do one more of those 5 fourth roots. Of 24x to the third times 4 fourth roots of 54x. So what are we going to do first? 5 times 4, which is 20. Multiply those front numbers. And then we have the fourth root, 24 times 54. 1,296. X to the what? X to the 4. And we simplify. Is 1,296 a perfect 4, I guess? It is?
Yes.
What's the fourth root? 6 again? And the fourth root of x to the 4 will be x and 20 times 6. 120x is what we would end up with for that. So I would multiply the two numbers together, both of these, combine them, and then simplify them.